Hi, this is activity number 8, sequential circuits analysis. We are the team number 5 and we are going to solve the problem number B. So, development. Build a state table and state diagram for the following circuits. So, here we have our sequential circuit. Well, first, here we have the behavior of a delay flip-flop. So we can see that when we have a 0, we are going to have a current state of 0, and when we have a 1, we are going to have a 1, and this is our Q negated. So first, we are going to obtain our equations. So the zero is equal, and here we can see an OR that have an X, or here we can see an OR, and this OR have an X and an Y. So our equation for 0 is equal to X or Y. And we have a D, and the equation for our D is equals to well, here we can observe an OR 2. So in this OR we have an X and an Q negated. Well, in this case we are going to call the Q Y negated. So here we have an X or Y negated. So once that we have our equations, we are going to build our truth table. So here we have our inputs and our states. So Y is an state, and the capital of Y is our current state. 0 is our output, and D is our delay or flip-flop. So if we see the behavior of D, well, we have that. So here we can see that when we have 1, we are going to obtain a 1 in Q, which is our Y. So for that, this column is the same that this. So to obtain our zeta, we are going to follow the equations. So we have an OR, and this is the behavior of zeta, and well, this is equal for the delay. We are going to obtain the values of the delay according to its equation. So once that we have our truth table, we are going to build our state table. Well, the state table is, here we have our current state and here we have our inputs. We have two possible inputs, x equal to 1 and x equals to 0, and well, we say that here in our truth table we are going to have our inputs and our current states, or no current states or states. So for that we have x and y. So here are our inputs x and here are our states, and well, here we are going to put our current state, which is y, and our output, which is 0. So for that, first, when we have an input x equals to 1 and our current state equals to 0, which is here 1 over 1 and 0, we are going to have an x, we are going to have an 1 over 1, because in the middle of our state table, we are going to have x over 0. For that, we are going to have 1 over 1. That it's here. And of that way, we are going to build our state table. And we obtain this. So when we have our state table, we are going to have our state diagram. Here we have our state diagram, and well, this is our current state, and this is our next state. For an example, so when we are in a current state of 0 and we have an input of 1, we are going to have an output of 1, and we have the output here. So then we are going to go to the next state, which are going to be 1. For that, we are going to here now. In our example, we are here, which is our current state. So our input is going to be 0, our output is going to be 0, and our current state our next state is going to be 1. So here, and then here, when we are in a current state of 1, and then we have an input of 1, this is our input, and when we have, then we are going to have an output of 1. Here we have our output, and our next state is going to be y, which is 1, and here for that we have again, here we can see that we are going to be again in 1. So if we have a current state of 1 and we have an input of 0, here we are going to have an output of 0, which is 1, and then we are going to be in our next state, which is 0 or y here.